Oh, welcome to Sunday Science, everybody. So, being our first and introductory episode, I figured I'd give everyone a little idea of what the show's all about. So, Sunday Science has been developed slowly over the last few months as an educational and informative show discussing current scientific events and providing our viewers, hopefully, with some simple yet exciting and affordable tests and experiments that can be done from home. I'd like to thank you all for taking a look at our show and hope you enjoy. Now that you're here, maybe I should go ahead and introduce myself. I'll be your host of Science Sunday. My name's Andy. A little bit about me, just so you know, some background. I've worked in manufacturing for essentially my entire adult life. Avid maker of do-it-yourself type things, experiments, tests, stuff you can use around the house. That's pretty much a love of my life that I've had for a long time. Got into doing a lot of this stuff because I happened to grow up very fortunately with a dad working for the USGS, multiple PhD. The guy was a hell of a lot smarter than me, but anywho, I was lucky enough to be able to go out into the labs with him, go out and do field work with him, head out to some of the big gold mines and copper mines, Arizona through South Dakota. Is a really great way to grow up. With the work that I've done, I've pretty much produced almost everything from mobile X-ray machines for the medical industry to aerospace components that are currently inhabiting other worlds, mostly Mars. Astronomy is definitely my favorite field. If you've seen any Sci-Strike shows, you probably already know that I'm an amateur telescope maker and absolutely love astronomy. Just started building my own telescopes a few years back. I actually converted a metallurgical lapidary into an optics lap and started grinding glass, kind of not knowing what I was doing, and I've just been running with it ever since. But I think that's about enough about me, so why don't we go ahead and get the show rolling. Knowing that the final orbits are taking place for 20 years of collaborative science from the Italian Space Agency through the European Space Agency and NASA's Jet Propulsion Laboratory, I thought a good way to start out Sunday Science would be having a nice little conversation about what's been going on with Cassini. So for anyone that's not entirely up to date or just started getting into this, Cassini was originally launched in middle of October, actually October 15th of 1997, and it's been an absolutely phenomenal almost 20 years at this point of, as I said earlier, collaborative scientific input from multiple space agencies, and the work they've been able to do, the data sets they've been able to get back are just absolutely astonishing. It's, aside from the Voyager program, in my opinion, Cassini has to be one of the most amazing joint scientific efforts of the 20th and 21st century combined. I'm sure there'll be more, but Cassini right now just takes the cake from my standpoint. Absolutely loving it. But a little bit about, obviously in order for a spacecraft as large as Cassini, they're not something that you can just launch off the surface and somehow hope, hey, maybe it'll get to Saturn. So it had a pretty interesting and intricate flight path early on before it actually wound up leaving any sort of orbit inside of the asteroid belt of our beautiful little solar system here. It 2 passes around Venus, once in 98 and again in 99, so that it could pick up the gravitational, slingshot effect necessary to actually gain the speed to exit and get all the way out to Saturn. During that time, it also made a single flyby from Earth where, while it doesn't seem like much, it picked up an extra 5.5 kilometers per hour of speed there, and it has just been providing immense scientific data ever since. So, obviously, people have been seeing tons of the Cassini imagery coming back, and one of the most awesome things about that is the entire imaging Science Subsystem, or ISS, and no, not International Space Station, but the Imaging Science Subsystem that's aboard Cassini is actually two reflecting telescopes. Both have 1024 squared CCD sensors, and when you think about it, for their time when they were made in 1996, 1995, launching in 1997, the imagery that we're getting out of them goes to show just how detail-oriented this entire construction was and how much people sat down and put into developing this technology so that we'd be able to have these views some 20 years later. It's absolutely astonishing, the work that people have done to make projects like this happen. It's just gorgeous resolution and phenomenal technology that's obviously helped consumer technology along the way as well. As far as those two cameras in particular that are the Imaging Science Subsystem, one of them's a narrow field of view 2000 millimeter focal length reflecting telescope, and the other one's a 200 millimeter wide angle. So you have about 0.35 degrees worth of field of view on the 2000 millimeter focal length telescope camera, and about a 3.5 degree field of view on the 200 millimeter. And those images have provided everything from the very first image Cassini was ever able to snap of Saturn when it was still, I want to say, 265 million kilometers away. So more than twice the distance between the Earth and the Sun. Cassini was just floating in the desolate void of space, and finally turned its cameras on, and there you go. The God of the Rings. Some absolutely phenomenal imagery. Throughout that, it also needed another boost while moving out there that Jupiter was kind enough to provide. Aside from blocking asteroids in 1994, it also helps us get a little boost on our way out. So, pretty cool stuff. Just sitting down, running through what those flight plans are is pretty interesting. And I actually had a video that I was thinking about sharing. It's from, I believe it's from the BBC. And if I can get this up for some screen share, they go through and they talk about what it is, why it is that the orbital mechanics work the way they work. I'm obviously not a rocket scientist. I'm a manufacturing engineer. So while I'm an enthusiast, I'm just an enthusiast.
Andy, does it have sound?
It does have sound.
Yeah, we're gonna have issues if you're gonna present. If you're gonna present.
That's right. We do have the sound issue. Oh, maybe I won't.
All right.
I mean, it gives the rundown of, okay, you need X amount of propulsion. Obviously, you have to have so much speed so that you can actually leave Earth orbit. We've generally spent the majority of fuel that we can actually fit on a rocket. So that by the time the Atlas 4B got Cassini into orbit, it was under its own power, and it had to be able to make these maneuvers with only what could be on board of the Cassini Huygens module itself. Apologies if I pronounce that wrong. I've listened to way too many Europeans say Huygens, and it's screwing me up in the head. But so effectively, with the amount of fuel that's capable of being on board for a craft such as Cassini and many other crafts, Juno included, they have fuel and propellant enough to be able to do basic maneuvers and make sure that they don't decay into an orbit, or make sure that if they do wind up getting in a little bit of trouble, hopefully they'll be able to pull out of that. But there's no longer a solid rocket booster or a liquid rocket booster attached to Cassini once it entered orbit. So in order to continue to get the thrust up after the Titan 4B was able to get it into Earth orbit, we had to send it around Venus twice. It picks up speed through slingshotting type maneuver and is able to start to gain enough speed that finally a couple of years later, actually 2 years almost on the dot, I believe, from what I remember. It's been a while since it was 1999, but there was a flyby of Earth at that point. And when it did conduct its flyby of Earth, it was pretty impressive, because if you were lucky enough to be on Easter Island, you may have actually spotted the Cassini probe looking like a satellite streaking through the sky. It passed at only 700 miles distance, and the speed that it had picked up from multiple orbits with Venus, and now picking up another 5.5 kilometers an hour from the Earth flyby, it finally had enough speed to actually get out and get to Jupiter and start the rest of its trek all the way to Saturn. It's pretty phenomenal the way that people have been able to actually sit down and figure these things out. It's almost kind of mind-boggling thinking about using a planet as a slingshot so that you can launch a craft that doesn't actually have a rocket attached to it. But we've been doing it for decades, and it works. It works phenomenally well. And, well, I don't know about the rest of you, but I just think it's awesome that we can do that. Awesome.
consider the math necessary to be able to do that. It's frightening beyond my abilities.
Oh,
it's frightening.
Absolutely. To be in the right planetary alignment, that you can calculate an orbital path for something you're going to launch out of, and know that you're going to be able to get these flybys, know that you're going to be able to pick up the speed necessary to run those numbers, and to actually get all the way to Jupiter alone is amazing. And then to get another gravitational boost off of Jupiter, just so that you can get out far enough to actually reach Saturn and start taking pictures before you're even in Saturn's orbit, it's just awesome.
I would tend to agree.
Yeah. So, let's see, when is it? It was 2004, I want to say. I think it was 2004, so when... No, it was Halloween 2002, that's right. So in Halloween of 2002, that's when Cassini finally actually turned on its cameras. And it got its first shot of Saturn, as I said, about 265 million some odd kilometers away. 285 million kilometers. And when you're sitting down and you're thinking about that, and you're going, how far in the world is Saturn from us? And I'm using a telescope to look at Saturn pretty much every night that I have the ability to. And still, you need something around 2,000 millimeter focal length from half the distance to get a good image. It's astonishing. Some of these optics just blow me away. Like I say, being an amateur astronomer, some of the stuff that people are able to actually make, it boggles my mind. I love it.
Understandable.
But yeah, so was it another 2 years? I think it was 2004 when Cassini finally entered orbit, and I think it actually did a flyby of Titan on its first entry into orbit, if I'm not mistaken. It's been a little while, but I think it was 2004 that it made its first flyby of Titan, which obviously Titan's been a moon of note for such a long time. We've known that it has a thick atmosphere for such a long time. Finally having something, a specific purpose, the Huygens lander, to actually set down on Titan. Just a wonderful event, and I think it was 2005. I don't know. It was almost Christmas 2004 that the Huygens actually finally detached from the Cassini module, and it was able to make a successful landing on an alien moon. It's the technology that went into this, the science, the collaborative effort. This is why I wish Science Foundations got the funding that I feel they deserve, because with such a small budget, with so many people not wanting to work with them or trying to stand in their way, they're still able to successfully land something on an alien moon in our solar system. It's, I know maybe a lot of people thought that we should have, human beings walking around on Mars already, maybe a space station around Jupiter, and I think we could be there if we would devote some money to it. But
if we had the funding, we'd be there now.
With the funding that we have and the funding that we had when this launched and when it was built, I would have to say, when you're sitting down and talking about something that launched in 1997 and successfully landed on Titan in 2005, that is an amazing achievement of mankind and of science as a whole. And the research it's been able to send back, some of those first images of Titan, they, cloudy, kind of mucusy looking almost. It's kind of an ugly moon, but as soon as the lander was actually able to get down there and start relaying data and information, it was just astonishing to sit down and see some of the stuff that they put out. And if you haven't already, I definitely suggest taking a look at JPL's Cassini file galleries. I mean, it's hard to describe some of this imagery. It's just mind-blowing. Not having any luck getting stuff that doesn't have sound, and every time we try and share something with sound, it doesn't seem to work. So maybe in future episodes, I'll be able to get some more of this functioning the right way. So stick with us.
Stand by. And don't forget in the comments topics that you wish for us to cover in depth in the future. Please put them in the comments, and I'll be jotting all those down. So
yes, absolutely. Questions, comments, anything that you guys want to know, feel free to ask, and we'll dig into them, and we'll get you the information.
Indeed, and Andy, tell me if I'm interrupting, but there's a let's see. I believe we have an anniversary. Do we not coming up, or not coming up? Yeah, hold on. The heck is it? Yeah, okay. So please stand by.
Hey, premiere episode, not everything's 100%.
There we go.
Yes!
I'm sorry for the delay. The machine's lagging a little bit over here. We've got a fairly big anniversary. Look at how long ago these fellas took off, and they're still doing. Running a little low on power. Away. Running a little low on power, but
that was to be expected.
Indeed, still doing the amazing stuff that they had, and we have what is projected 10 more years with reducing functionality over that period, and after that, it's just a messenger out to the rest of the universe.
So, just a robot with golden records.
Indeed. Hopefully someone snuck in and managed to write on side. Please do not blame us for previous past bad behavior. We're much better.
Yeah, now. Right.
And hopefully by the time anybody finds it, we'll be much better. We shall see.
Indeed. Anyway, who knows? Maybe in a couple more decades we'll pass them on our way out, trying to finally get somewhere.
That would be an interesting thing. All right, but yeah, with such a big anniversary,
probably more than a few decades. I'm an optimist.
Yeah. Well, you're not the only one. Kind of have to be, but we might want to dedicate a show to these two fine little entities flying off into interstellar space at some point in the future.
That could easily be next show.
Indeed.
I don't think that would be a problem whatsoever. Because we're up. Well, let's see. The 15th, obviously, is the end of Cassini's mission. Unfortunately, it's finally spent all of its propellant. Its orbital maneuvers are about to cease. But in between then and there, don't want to just jump to the end of Cassini's entire life. It's been an amazing time for it. Uh, it was pretty awesome, actually. I remember this one almost like it was yesterday. Back in 2006, it was just a couple of days after my birthday, and at the time I was working for a company in Boulder that was Boulder, Colorado, that was uh, deeply involved in this type of work. And we got news over at the shop that I was in that it was just about completely confirmed at that point that there was absolutely, without question of a doubt, liquid water on Cladius. And that might have been part of the thing that really branded Cassini into being such an amazing mission for me. It was not just because it was right around my birthday, but because there was, without question, liquid water. Not the potential for a subsurface ocean. There was liquid water. No questions asked.
Kind of a big deal.
It's, I would say, one of the greatest scientific discoveries in, well, definitely of this century. Just everything that the mission has been able to do with some 12,000 flybys of Enceladus, the landing on Titan, being able to actually sit down and measure methane content, atmospheric content. Is this a potentially primordial Earth-like atmosphere? The information, even though there's only a few days left for the Cassini mission, the data sets, the files, the knowledge that's coming back is something that's going to be able to be studied for another 50 years and still be making discoveries. That's what drives science. You can make an entire career off of that one little thing, and it's just amazing. I love it. But around 2008, the initial Cassini mission, actually, it was completed. It was done. It was over. But with everything that they had already discovered at that point, with everything that they had done, they were able to get, in fact, 2 more mission continuations, or yeah, I guess you could call them continuations, or mission extensions, I guess would be the right word. And through that, that's why we're all the way up now into, once again, I got another lucky break for my birthday, and Cassini made its 100th pass of Titan 1 day before my birthday in 2014. So maybe I'm a little bit addicted to this particular spacecraft, and Saturn as a whole. It's got to be the most beautiful planet in our solar system, other than ours. But I've definitely had some good luck for my birthdays with Saturn flybys. It's pretty awesome to have that sort of coincidence take place in your life. It probably doesn't happen very often. So how in the world can I get some of these to share the right way? And of course, now my mouse is frozen. That's awesome.
Joyous. Love when the computers behave. I always say, trust the machines. They know what to do. But sometimes they screw with us.
Oh, yeah. Well, I mean, they're only as good as the people that made them, so.
Yeah. In the meantime, you want to see what the Pluto video, extremely low res, as I'm told the images here. This is interesting.
Absolutely.
This is what we have. We don't have high res moving. This is what we got at the moment. I still think it's pretty damn cool, considering the distances involved.
Not only the distances involved, but to actually to get the chance to watch something orbit its own planet.
Yeah. Wait. Pluto's been unplaneted. Heck.
I don't care. It's a dwarf planet, still a planet. It's just small.
Yeah, planet's in the name. That's good enough for me. But
right.
Anyway, could do
fine. Watching a moon orbit a dwarf planet.
Absolutely, and at the distances
and
involved,
a couple of moons, actually.
you were talking earlier of the complexity of using gravitational slingshotting and all that sort of thing, and for both course corrections and speed enhancement, and think of the calculations it took to get to even this point where we didn't have good non-pixelated images yet. Truly amazing.
Indeed.
Alrighty. Well, okay. Yeah, I just thought I'd throw that in there. I'm rude like that, you know.
Oh, definitely a good one. I like it. Which, New Horizons is another one we're going to have to sit down and make an episode about. I don't think New Horizons is quite as impressive, but like I say, I might have a weird addiction to the Cassini mission. I may have made parts for it. I'm not 100% sure. I know I made parts for Phoenix. It's been a long time. Made a lot of parts for a lot of stuff.
Mm. What I'm slightly sad about is I believe that the asteroid redirect mission has been put off, that it's not funded for the next cycle.
That's unfortunately what I heard as well. It's lost its funding.
That was going to be an amazing mission.
Absolutely.
When I was actually at Goddard, they had the mock-up. They make the small models and the big models and the full-size models and all that sort of stuff. And one of the most interesting things was the gripping mechanism. They used insect theory, that several 100,000 little tiny hooks that all just poke into the surface, and each one provides near zero grip, but cumulatively it's be able to grip so that you're not going to separate the two. It was definitely even that, not just the getting there and all the math necessary, but I stood looking at that for probably a good half hour. But
it's Velcro on steroids. They invented it once. Now they can repurpose it.
Indeed, but yeah, I mean, I'm sure it's coming. I mean, that could be a planet saver at some point, because and I'm not cooking this up. This is what they told me, that the redirecting of one moderately sized asteroid, well, what if something huge is headed for us? Well, they went on in great detail about using the gravity well of that object to redirect an even larger object that was going to do us serious harm if it should get too close. And that I'm sure it's not completely off the map for them to design something of that magnitude. I'm sure it's just put on the back burner for other projects that were prioritized. But I'm definitely looking forward to that.
There have been some pretty major projects that have been backburnered, and Hubble is probably the most famous backburner project in all of NASA's history. It's a shame they didn't sit down and take the time to inspect those mirrors while they had the downtime, not being able to launch when they wanted.
These things happen.
Hey, adaptive optics, we can make it work.
Absolutely. And the Hubble, that's another area of interest for me. Obviously the imaging, we've all seen images from Hubble.
Oh yeah,
beautiful, and it's a great piece of machinery up there. But oddly enough, what impressed me the most about Hubble is no thrusters, no impulse engines, no drive whatsoever, no thrust, no rockets, nothing. All of its change of directions, repointing to different is all done through inertial drive, through the slowing and speeding up of spinning wheels on multiple axes. It might be an odd thing to be impressed with, considering all the beautiful images we've seen, but the thinking that went into that was pretty sharp as well.
Oh, absolutely. The mechanics behind it are hard to actually rationalize in your brain.
Yeah, and what else is kind of hard for us to accept as possible is still spinning.
Right?
The inertial wheels are still spinning as they were initially designed to do. That in itself is pretty amazing. Anyway,
Absolutely.
yeah, Hubble's a good one.
Hubble is a good one. I think that'll be, obviously, test episode. Maybe we don't have everything in line, but we'll get there.
Agreed. I would definitely concur. Let's see. I didn't see, unless I missed some, I didn't see requests for future things to dig into yet. You know what I am seeing? A heck of a lot of good information, as usual, coming from the public chat. Anytime we do any kind of show, we get as much info as we give.
We do, actually. It's pretty awesome. I really like that about everyone that's on here. It's a pretty phenomenal group, if you ask me.
That definitely does seem to be the case. And we've we've never had any just. Oh wait, one time we did have somebody that was I don't even remember who it was that came in and was just spouting nonsense to try and disturb the proceedings. Anyway, once in a year
you
and a
always
half.
wind up with a couple of. I mean, it happens.
Absolutely.
Not a lot you can do about that.
Okay, Tao's back. Tao says, "At least you don't have to drink too fast." No, there'll be none of that. There'll be none of that. As we mentioned, this is quite serious.
I'm not going to say that you can't drink beer, but drink it slowly.
Indeed, it's a Sunday. Relax, enjoy yourself, and
right.
Hopefully, we will all learn from each other, as always is the case.
Exactly. That's the only way that education ever actually works, is for everyone to learn from everyone else.
Indeed.
You can try and put yourself out there as some grand educator that knows everything, and that's, doesn't work.
Met a few. You're right. It doesn't work.
No, the best teachers I've ever had have been the teachers that don't try and place themselves above you, but treat you as an equal and help you, as opposed to tell you.
Indeed.
There's such a drastic difference there in the world of education, being told something and being taught something.
Indeed. And there's the two-parter that I love best, because it's the beginning of learning for everybody, is I don't know, that's part one, but let's find out, part two. That's my favorite.
Yep. I would agree.
Looking at the names scrolling by in the live chat, I'm kind of hesitant to put out for the simple science experiment. For these people, it's like saying, take the block with the A and stack it atop the block with the B. That is your mission for today.
Oh no, we have to roll out the simple, and we don't even actually have to call it simple. It could be homemade science.
Well, it is. It's meant to be. It's
not rocket science.
Yeah,
so.
we've always said science is for everybody, and some young fella or young lady doing a simple experiment, or one or two after another.
Someone looking for a science experiment to do with their kids for the science fair.
Indeed, these simple things like this may trigger an interest in the sciences in general. Hell, we need more climate scientists. We need more space scientists. In general.
Brian Stevens is requesting a LIGO and Chandra X-ray Observatory segment in the future. That I'm all about.
All right.
When it comes to any sort of stellar observatories, absolutely.
Alrighty. Okay, is RJ responding to somebody, or does he want an in-depth on Pluto and Charon?
I have no idea.
I'm writing it down anyway. It that's kind of a cool topic. All right.
Pluto and Charon are actually a pretty cool concept. I mean, when you get right down to it, they are the only other closest thing in this solar system to a binary planet is the Earth-Moon system, and they're so much closer that they destroy the idea of a binary system being an Earth-Moon system. I know that's a little fringy, but it happens.
Nobody say Nibiru. Nobody say Nibiru.
No, there is no such thing.
You think?
Whether or not you want to consider two astronomical bodies a binary system or not, that has nothing to do with pseudoscience. That just has to do with how we describe particular things that do exist, that are real, that we can see, we can look at. And hopefully in the future, we can step foot on in some capacity.
Absolutely. Right.
So, we were talking about Cassini.
Oh,
so,
yeah. I got us off the topic. Sorry. I was just thinking.
No worries.
Just thinking of that 40th anniversary. That's amazing.
Well, for some reason, my not being able to share these images, I was hoping I'd have my laptop up so I could run on two screens, or my PC up. Instead, I'm on my laptop, and it's just the back and forth is not working out for me too well right now. So once I get that figured out, hopefully next week, or my PC set up, we'll be able to do a little bit more image sharing. But so much with the imagery of Cassini is
images you can do. It's just, remember, sound is the only problem. If you want to put up, if you want to screen share and do some images, you can.
It's the wireless card in my archaic laptop that I'm running right now because I broke my good laptop tripping over a dog.
Oh my.
So I have a wireless card that I don't think was ever intended to be used with the DSL modem, and it's every time I click off of our Hangout screen, I just get a white screen.
Oh, lovely. All right. Understood.
Yeah. It's a blast.
Understood.
So I figure rather than bog the show down by trying to upload an image, I think most of us watching have seen so many of the spectacular images that the little image section we could probably jump over this round.
Indeed. All right. Very good.
But as far as some of the greatest images, though, that first ring dive back in April this year, wow. Just wow. And the sound, this is one of the ones that definitely I would need the sound for. Saturn sounds awesome. I know it's a really weird thing to say, but the planet sounds awesome. I don't know if you guys have ever taken a look at any of the audio files on the Cassini Mission page over at JPL, but it's spooky and awesome. Is there any way you could show those, Si?
You send me link, I think I can.
Where in the world to go?
And
redirect? No, not that one. What in the world happened to it? Oh, I did have it up. Like I say, archaic laptop, it has problems.
These things happen.
Indeed.
Let us see. In the meantime, here's what Cassini's been up to. Apparently just having a grand time. Let us see. Alrighty. That up.
Oh, I think that's one of the good ones, if I can...
Okay, we're catching the audio, strangely enough.
Well, that's pretty awesome that you caught the audio. That's on Claudius.
Yeah, Hangouts has always been sort of funny on transmitting audio front. You'd think there'd be a setting for that to accept and retransmit audio from videos.
You would think. That was a little weird that you guys heard that.
Yes, normally the echo cancellation and all screws up outgoing audio, but did copy that. You know, when we were doing the Eclipse thing, that was one thing that I forgot to do, and you'd think, being in the ham radio hobby, you'd think that would have been right up front in the brain, which was, you know, that our son is a really good, high-powered radio broadcasting station, and I was thinking how interesting it would have been when the eclipse happened to document a dip in the signal strength and all that sort of thing. All right.
That would be fun.
But I did not think of it. I'm going to have to wait, what, 7 years?
Ooh, Tau, I definitely agree. The hexagonal storm on the north of Saturn is one of the most stunning things in the solar system, I think, by far. That's just awesome.
Alrighty, I got the
So that's the general audio file. I don't know why in the world you guys heard audio I played, but I want to say it was passing between the D-ring, I think, when Saturn actually echoes and makes its weird bellowing noise.
Oh, God, the Cassini's first D-ring crossing, that one?
I believe that's the one, yes.
Let's see what we got. Okay, was that the one? First off,
that's pretty much the one I was thinking of. Just absolutely terrifyingly spooky. Makes you think about that Event Horizon movie.
Indeed, I was always impressed by that. The oddities in the RF emanations from various bodies.
They are pretty wild.
Indeed. All right. Actually, that works surprisingly well.
That did work pretty good.
All right.
Well, I'm definitely learning a lot on this one.
Indeed, and actually, I rather enjoyed that sound file. Okay, let's bring this back up. All right. Anything else? Any other requests for stuff and things?
Always open for any requests about science.
Okay. Andrew, it did not sound like a fart. Let's see. All right, I have written down our requests for future events. And very good. So, what do you think? Do you have more, or is it time for simple science?
I guess it's about time. Maybe give a little description about what simple science is. So obviously this week, SciStrike will be our presenter for Simple Science. And the idea behind Simple Science was that we would be able to either take experiments or tests that viewers were interested in seeing conducted, or those that we had concocted on our own, and actually sit down and give you guys the chance to see them taking place in person. And one of the main focuses of Simple Science isn't necessarily that it's simple, but that it's something that everyone can do, everyone can learn from, and that it's something that's affordable to do from your home. It's not something where you're going to need to be, you're not going to need to outsource parts to a machine shop and have stuff made, or learn how to blacksmith your own iron so that you can test metallurgical anomalies. It's what you can make with stuff around the house and what it takes to actually go ahead and do it, and testing its functionality.
Indeed. And as we mentioned earlier, the goal is to make sure that everybody knows science is for everybody. There is no one on this planet that is not capable of benefiting from, the learning you get from doing things yourself. Can spark interest, can teach you things, and that's really the goal. I'd like to see people, become more interested in that sort of thing. All right.
Absolutely.
That being the case, to all the big brains in the public chat, I'm sorry. this is going to be a little bit below your level. But as we said, it may be a benefit to younger viewers, people that want to do science fair projects with their kids, things of that sort, or just someone who has an interest in anything of this sort. Today's topic for Simple Science is a homemade barometer. So here we go. And it was recorded previously because, as you all know, anything over 15 seconds I start saying So, here we go. Hello there and welcome to Simple Science. Today's project will be a homemade barometer. A barometer is an instrument measuring atmospheric pressure, used especially in forecasting weather. The supplies you'll be needing for this project are as follows. A glass jar with a lip around the opening. A large balloon. A soda straw or long coffee stir. Some glue, and this should be the kind of glue that works on plastics. Scissors, do not run with them. And a roll of electrical tape. Alright, let's get building. First, cut the balloon in half. The dome-shaped half is the half you're going to be using. Stretch the dome half of the balloon over the open end of your jar. This is where the lip on the jar was important. It helps keep the balloon in place. Wrap one layer of electrical tape around the open end of the jar below the lip over the cut end of the balloon. This will hold the balloon in place further and keep it from sliding off. Add a drop of glue to one end of your soda straw or coffee stir. Stick the glued end as close to the center of the balloon as you can get it. Use the roll of electrical tape as a weight to hold down the straw or coffee stir until the glue hardens. Congratulations! After the glue is dried, you have a working barometer. You'll want to print out a graduated scale or use graph paper that you've numbered to help you track the readings. Check and record your readings several times per day. Record your readings every day. High barometric pressure will cause the balloon to be slightly sucked into the jar, causing the other end of the straw or coffee stir to rise. Low barometric pressure will have the opposite effect, causing the balloon to be pushed slightly upwards, causing the other end of your soda straw or coffee stir to drop. Over time, you'll notice that these readings will help you to accurately forecast changes in the weather. Well, I hope you've enjoyed this episode of Simple Science. We would just like to remind you that science is for everyone. And thank you for joining us. There we go. That's what we got.
Awesome. I like it.
That is this week's Simple Science. Hopefully some young fella or young lady will learn something from that and possibly become interested in climate science or something of that sort.
Absolutely. It's amazing what a simple experiment can get someone addicted to.
Absolutely.
I know one of the first ones that really captivated me into the world of science was, it was actually really simple. It was just seeing one of the guys in the rock lab over at the USGS running a lapidary machine, and how it is that you would polish a specimen so that you could get it under a microscope and start analyzing it. And more of that fundamental end of the work, since I was so young at the time, it was really awesome to look at just this weird, rock, watch them go through all the different cutting processes to get it prepped, get it through a lapidary machine, all the different grits to get it to a near mirror finish, and then finally actually bring it in to the telescope lab. That's definitely one of the ones that really captivated me with, well, eventually going into metalwork, just cutting stuff and polishing stuff.
Alrighty.
Simple science experiments. They can do wonders for young folk.
Absolutely. And obviously we're going to be talking about mostly the non-exploding ones for you folks in the public chat. I'm reading. Yes, I'm reading what you're writing.
Mm-hmm.
I see any of you with Erlenmeyer flasks strangely bathed in dry ice. I'm going to know what you're up to. All right.
Yeah, that's definitely one I would suggest not attempting, ever.
Alrighty. Anything else you'd like to cover, Andy?
Not much that I can think of just right at the minute.
Alrighty. Well, darn good introduction, premiere for your show, and we will take.
I think so. It seems to have gone pretty well.
Yes, we will take the request we've gotten and anything else we can find, and
absolutely,
and then collate and devise some interestingness for next week.
Sounds awesome to me.
All right, and for the public chat, we're getting close to wrapping it up. So if you have any requests or things you'd like to see or like to hear about next week or in the following weeks, now's the time. Or you can email. There's an email address in the link. Feel free to send requests to that as well if you don't think of it now, but in a half hour. Geez, I'd like to hear about this. Feel free to email it, and I will get it immediately over to Andy.
And it can always be left in the comment section as well.
That too. Alrighty.
Oh, I think that was a good first run.
Indeed. Damn fine show you got there, young fella.
Oh, it's going to be a work in progress, but I think it's going to be a lot of fun.
I would tend to agree. All right. Let us bring on the closing with that fine musical selection, shall we?
Let's go for it.
Alrighty. Thanks, everybody. Had a great time as usual.
Thanks for coming, everybody.